let's get started. Thank you everyone for tuning in. And my name is Kyaw. I'm with Lavi here and people from MachineHack. Thanks so much for having us here. And it has been amazing working on this project together. And Lavi and I have a lot of sync up for this. And then we decided that we want to do something that is benefit for the hackathon participants, right? So the hackathon is pretty much focused more on the BigQuery and getting the machine learning things out. And we want to give you all the information that we can give you to be successful in this hackathon, right? That's why we are having this sharing section here. And we will be sharing two portions. One, like for me, I will be talking more about Cloud BigQuery, and Lavi will then go through, what exactly are the materials that he has prepared for you to be successful in this hackathon. And I hope these are useful for you guys. And first thing first, what's BigQuery? Right, so the BigQuery itself is pretty much enterprise warehouse solution, right? So nowadays we live in a world where the data are everywhere, right? You have social media data, you have transitional data, you have pretty much all the data from IoT devices, your mobile phones, everywhere, right? So how enterprises can use a solution that encompass all the data storage into one place and make sure that the performance of scaling, make sure that the ease of use and all these sort of things. So we came up with this product called Google BigQuery that is suited for enterprise data warehousing and is petabyte scalable, right? So you can put a lot of data there and it's scaled really well and you can query things really fast, right? So I will sort of go deeper into why is this the case, and we don't really require to learn any extra skill set. If you are from comp science, if you have a IT background, you pretty much learn how to write SQL query, right? So you use SQL query to query things from BigQuery, and then you get like petabyte scale and fast kind of performance from using this product. And if you're into database a little bit, you probably heard of things like collinear data storage, where we use for BigQuery, right? So traditional databases use row-based data storage, but we are using column-based data storage, right? The reason being, most of the SQL statements, we do select columns, right? So it makes sense for SQL to have the column-based data storage. So when you write the query, when you filter by column, right, it sort of makes sense to have optimized collinear data storage, right? So this is what it is. So we were trying to cater for the usage, but how would a user use it? And then how would we optimize it so that user have all the performance required, right? Everything's optimized and it's quite fast. Also, right, if you are in data space or maybe in programming specifically, right, you create apps and not everything just come in one line, right? Like not just one row, right? It will be a struct where you have attribute nested columns. There might be a list of things. There might be an array that you need to store, right? So traditional SQL databases, you don't really support that kind of primitive data type, right? So you probably have integer, float, varchar, and things like that. But for BigQuery, you can actually store things like struct, array. You can even install analytical functions. You can even have like approximate aggregation, things like that, right? So not just traditional storage, we have all these things additional that you can do if you use BigQuery. And of course, being a database solution, it supports DDL, like create delete statement, right? You can also create scripting. So if you are DBA, you're probably familiar with things like store procedure and things like that, right? So we also support those. And like create, delete is not all the things. You can also insert, update, you can merge the two databases. You do all these things, right? DDL and DML script is also supported, right? So pretty much you can treat this as a traditional SQL database with all these external functionality that we built on top of it, and it gives you a petabyte scale and fast kind of performance, right? And nowadays, data security very important, right? It's not just storing or not just how fast the things is, it's also about how secure, right? So how do I know the data that I store into a Google BigQuery is secure, also is available, right? Like you can have a product that is really fast, but it down most of the time, no use, right? You can be, you have a very fast storage, you have a very strong storage, but it's not durable, right? You can lose data anytime, also no good, right? So what we have provide is that we are encrypting all the data, incoming, outgoing, in the key rotations are done because it's fully managed service and it's also serverless. So you don't necessarily have to procure a server or the infra to be able to use BigQuery, right? So we provide fully managed serverless. So all you have to do is just go to the panel, start writing SQL script, and then it works as it is, right? And because it's encrypted, data are okay and doable, right? There's a high availability, I think 99.99% or something that is promise that we are providing, right? So a little bit more into technical stuff right now, but this is more like a general introduction of what BigQuery is. Long story short, SQL kind of data warehouse solution that has all the others additional functionalities that Google have built. It support everything that SQL support, right? DDL, DML, from the security side, encrypted, doable, high maintenance, and also the managed serverless solution, right? So go deep down and into like why does it provide like a fast and the petabyte scales kind of solution, is that you split your SQL solution into two parts, right? One is storage and the other is compute. So you are not sharing resources in terms of storing and compute. So, and they have like an internal buffer where you have a distributed memory that can shuffle, right, between this distributed and the computing. So if you are from com science or any of the IT related courses, you probably know some architecture of our servers, right? You have a storage and you have like a RAM and you have like a hard disk space. So when you process something, you got to transfer the data from either from a RAM or either from a hard disk into the processing space where you can start computing, right? So how this architecture makes sense is we have all these high availability cluster of compute, and there's like distributed storage with like a very high availability and durability, and we connect them using petabyte networks, right? So things like that is like if you want to query the data, your data really go into the cluster through this petabyte network, which is really fast and it's also distributed memory, right? So you don't have to just wait for things to happen because it's all distributed and it can just go, right? And that's for computing, but how about ingestion, right? So the ingestion, it has a different sort of path that you can take. So if you are streaming, the streaming ingestion go directly to the distributed storage, right? So when you are ingesting something to SQL or databases, you don't necessarily have to compute stuff, right? You're just inserting to it. So we split it out into another path where you can do bulk uploading or streaming ingestion, right? So this is where you are not impacting the performance, even if you're doing the loading job, right? So this is how the architecture is formed. And of course, if you are a user, right, you can create REST API, you can create web UI, you can do ODBC, GDBC, and you can use like 7 languages like Golang, Python, Java, C++ to query from this database, right? You can even use native SQL to query this as well. So this is how we architecture it. And because we split into storage and compute, so you could just, if you are just storing the data, you're not touching the compute cluster, you're just computing, then you're not touching the storage cluster, right? It's also nice for billing, right? If you are just uploading the data, you don't want to get charged for compute because you're not using the compute, right? So we also split billing into these two different category, right? So this is some example of how fast and how you would query in BigQuery, right? So you write statements like select, this column, that column from this table, and then you get your results, right? And this is built in. So all you have to do is go to cloud.google.com/BigQuery, and then you can find this editor window there, and you can import your databases, you can use the existing data, and then you start writing query, right? So you don't have to install things like administrator dashboard, right? So if you're using traditional SQL, there will be like PHP admin and all sorts of things. You don't have to install those. We already have this editor for you to do it. And then it will basically tell you how much you will be querying at the right corner. So around here, you will be knowing before you even press runs, you will say, okay, your query going to process 2.8 terabyte, right? If you feel like, hey, no, I don't want to process that much data, then you can change your query, right? So it's like a preemptive telling you that you're going to query this much. And if you don't want to, you can change your query it again. And if your query is wrong in a sense, and there won't be a green tick showing up, right? So it sort of makes sense. You don't waste your time. You don't have to run it and then find out what's going wrong, and then you try to come out again, run again, kind of thing. It's sort of like do a pre-check for you, right? And it's also process is really fast in distributed manner. So like you see from this particular piece of GIF, you can see we process about 500 gigabyte of data in like a few seconds, right? Like 5.6 seconds for 528 gigabyte of data. So this is like because we are distributing it, and you can see how it would have, it would last or it would take to compute it if you're not doing distributed and distributed. It will give you that kind of statistic, so you can take a look and see whether it makes sense to do it, right? That's one plus point for BigQuery. And of course, if you are talking about machine learning side of things, right? So when you are building the machine learning models, your tasks involve things like optimizing the model, right? So you have a small data set that your managers or your team lead has given to you. You use Jupyter notebooks to try to train a model using, very small set of data. You are trying to do ETL, like extract, transform, and load data before you train the model, right? And you also have to do infra management, right? When your model is being trained, you have to publish it to the API, you have to pass it to the engineering team, you have to upload it through Kubernetes, all sort of things, right? And you could also have to do for not only for the training, but also for the prediction, right? Inference, right? Once you upload the model or you launch the model, you have to do exact same ETL steps for those upcoming data so that your models can take in those data and predict it, right? So those are the steps that we actually support from BigQuery, because BigQuery, like I said, you can create scripting things, you can create model training exactly on the BigQuery itself. You don't have to install things, you don't have to create your own notebook environment, you don't have to use Anaconda, p-install, things like that. It's support on the box itself, right? And so some of the things that you might be wondering about security and compliances, right? Like how, let's say your data is subset, but it's a bit sensitive, right? You have to take the data out from one environment to another's. You have to go through approval, right? You have to request for it, take times. So how would we then, use this kind of database to smoothen this kind of pain point, right? So that's exactly why we are introducing this BigQuery solution. So in a typical workflow, this is how it is. You either use streaming data or you have batch data. You upload to BigQuery, right? And your BigQuery data have all the data that you need. So you will start processing your data. You will export your data, right? So this is where data governance issue comes in. Can you export it, right? You are from different team, for example, you need a permission to export it out, right? And then you probably train your model using Python or R or Julia or any sort of languages using your local environment or notebook, right? Or even if you're using server, you have to manage the resources, right? Do I have a GPU or do I have a strong enough CPU to train my model, right? If my laptop even can handle this kind of data that I exported out, right? Usually laptop RAMs 16 GB or 32 GB. If your data are like 1 terabyte, you probably cannot train, right? So something like that. And of course, after you train your models and you deploy it, right? Like where do I host it? And that sort of introduce things like you have multiple products and roles have to be coordinated, right? You probably have to have a lot of team meetings, right? Like teams against teams, and then adjust the timeline, right? I try to get more people on board into this just to push it out, approval after approval. It's introduced a lot of complexity and it's also cost involved in it, right? So how would BigQuery solve these kind of problems? Is everything like you want to export data, you don't have to export outside of it, right? You can just export it into another table or a view. So ideally, your data are still within the environment, so you don't have to necessarily go through the governance side, right? If you can select from the table, you have the necessary data or permission to export out the data into like different view, different table. So you don't have to go through that kind of thing. And if you want to train machine learning models, You don't have to procure additional resources because this BigQuery is serverless and fully managed solution. So we procure the resources for you to train a model. And once you train a model, right, you could also use ML serving from Vertex AI within the Google Cloud environment to host your model, like directly from BigQuery. So that's sort of like smoothing out these kind of issues and complexity that is introduced in the traditional ML workflow, right? So if you use BigQuery ML, you will just be using one environment to do all these things. And if you have to like keep tuning the model, if you have to create new models, you have to update the models, it makes it a lot easier because all you have to do is just rerun the script, right? It's entire end-to-end processing, exporting, training, deploying is like one SQL script now, right? It's not just you have the XML data file to upload into a server. You have like junking files to run the things. You have like all these tests that are going on. You have like a requirement text from pip to install stuff, right? You probably use container, and then you have like Docker files to spin off the containers. All these things are minimized, right? So exactly one place that you can do everything without having to install anything. And you don't have to care about dependency things. You don't have to care about whether the new package that install going to conflict with the existing package, all these sort of things, right? It sort of make it simple for people to get, use the model. So our goal is to just have the model from the data, right? So this is why we are sort of branding in the sense that we introduce tools that can travel you or rather bring you along from having a data into serving a machine learning model. Right? So these are the tools that we are going to work with. And yeah, not only all these things that I mentioned, there are things like, if you want to train a model or tune a model, sometimes it's complex and time consuming, right? And if you have pipeline that coming in from different data sources, you got to update them, right? And if you're just using traditional ML flow, right, data ingestion, probably using like Apache Beans or some other, data toolings, right? You might have Airflow pipeline here and there to schedule it, right? And your next steps is to transform the data, process the data, train the models and things like that. And they don't really talk to each other sometimes. So if your loading data jobs fail, right, then your model side or model training side do not know like necessarily whether the data is fresh or not, something like that, right? And someone has to come in and say, hey, you can't export the data out from this system to that system. So you need to have like a data governance team that looking over all this sort of thing. And if you are like, really creating your own custom models, really pushing the boundary of what the machine learning can do, you probably have to start tinkering with all these. You cannot just use Keras.fit or something, right? You have to start going deep into the toolings, right? And that means you have to push your boundary, right? So there might be some of the functionality only available in the latest version of the package, which doesn't necessarily work with the existing packages, things like that, right? So you will need advanced programming skill set, right? Make it into a module. How do I, sanitize my data? How do I put a test to my data, right? Measuring data drift, model drift, all these things, right? It come into play. So it's not just about, I have a data, I train it, and then I self model. So enough of all these problems and things that we have to solve as a machine learning person. I would like to introduce you these tools, or rather the offering from BigQuery is called BigQuery ML, right? So if you just only know SQL and like your managers or your lead say, hey, I want you to start learning machine learning. And the first thought will be like, oh, do I need to learn Python now? Or do I need to learn some other languages now? But the quick answer is no, because you can train machine learning model using SQL, right? So you don't necessarily have to touch Python or some other languages. You just need to train it on SQL. And because BigQuery provide all this end-to-end workflow, right? So you don't have to move the data from anywhere, right? Because you're using BigQuery, you're housing your data in BigQuery, you're training model in BigQuery, and right? So pretty much everything is in one location. And once you have done, right, you can also start automating it using the scripting, right? Like store procedure or some of the scripting. Then you can start automating the task. right? And because all the security, compliance, and infra managements are being handled because it's a fully managed service, right? So you don't have to worry so much about, hey, if I train this model, do I have to procure or this particular piece of resources, how many server that I want to scale on, things like that is done automatically for you, right? And it sort of make it a lot easier if you talk to the compliance side and security side, right? Whether data is secure or not, because data have never left the environment in the first place, right? So they've probably done all this compliance check and security check for you when they onboarded BigQuery. So as a developer, I don't have to care so much about all these other things that not necessarily my interest to learn or interest to do. So that's one part. And to create machine learning model is also very simple. You just have to say from the GIF to the left, right? You just say from this, right? And train this model, create the model using particular keywords like logistic regression, linear regression, things like that, right? So it's only in 2 steps you can do. You create a model, right? Like you can see from here, create models, option this, where are my labels, right? What are my data? And what kind of model. You can also define things like parameters, the max number of iteration and things. After you have the model is also stored in the BigQuery environment. So you don't have to download anything. You just use the model again to predict it. So the prediction also stay in the BigQuery, right? So it's all one nice family of things going on. All right, so our sort of goal is to democratize the machine learning for everybody. So not just Python users or not just the developer, right? So if you're an analyst, you can also build your SQL model. Right? If you are a DBA, you can also build your ML machine learning model, because now it's like you don't need Python anymore, right? To create models. If you're using BigQuery, SQL is the way. So you use SQL to do it. And then all these securities and complexity also taken care of for you, right? So you don't have to worry so much like, oh, will I have enough resources to run these particular things? Or do I need to learn Python? Or do I need like Jupyter Notebook or things like that? You don't, right? So if you are familiar with SQL, you're good to go. And we are adding in new models, features every now and then, right? So we have a roadmap that we go through, right? So for classification right now, you can do logistic regression, XGBoost, some popular one. And if you're adventurous, you could also try to do wide and deep neural networks, right? So pretty much almost everything that you can do there. And other things like k-mean clustering, time series focusing, anomaly detection, you can also start trying. Right, and if you talk about regression, right, like you can still do like pretty much almost similar to the classification, just that is a regressor, right? And for DNN regressor, we are supporting TensorFlow. So if you are a TensorFlow person, and you could just build things that you would build in TensorFlow, and then it will just work there. Okay, so there are other operation things that it support as well, right? So if you want to import TensorFlow model, you can also do that, because DNN regressor is ideally TensorFlow backend, right? So they sort of work interchangeably. You can also export model from BigQuery ML to somewhere else like Vertex to do online prediction, right? And not only that, you can use like AI Visor from Vertex to do hyperparameter tuning, right? You can use with explainable AI to find out how the models are making decisions based on what kind of predictive measures, right? So it's not just, oh, I have SQL panel, I train models, and that's it, right? So there's a lot more things you can do even after you have trained the model and you are training it on SQL environment. Right, so I talked enough. I think there's a lot of things that you need to cover for the day, but if you are interested to learn more about how to design patterns for BigQuery, you can go to this link, like goo.io/BQML use cases. And there are a lot of video out there that Developer Advocate has been creating, and you can take a look at that and see how they use BigQuery ML to build or solve some of the problems, right? So that sort of like give you a very nice overview of all the things that you can do with BigQuery, and see how that can, help you in this task, right? So once you have understand how people are using BigQuery, and you can sort of make use of their experience or their sharing and apply it into the current task of Hackathon. And hopefully you score the best, right? And there are prizes, if I'm not wrong, involved to the top teams. So this is where I leave you with. If you have any questions, you can put in the Q&A, right? I will leave this to Lavi to share the second half of things. Yeah, thank you so much for attention. Yeah, feel free to reach out and ask question. Yeah.
So yeah, you can also share your LinkedIn on the chat, just in
Ah,
case if people would like to reach out. And there are a few questions in the Q&A.
okay.
I have addressed some, but it'll be great if you can pick them live.
All right. So there are open questions. What are the other replaceable options? There might be some other replaceable options. So one question is we answer live, right? Can I? Does it open up the questions? No. Okay. So there are different ways to do machine learning, right? First of all, there's one direct sort of replacement, for example, is you use like Vertex AI entirely, right, to train the model, right? So we have BigQuery, which is also from Google product, but there is more SQL side, right, like big data storage and things, the data warehouse, enterprise data warehouse solution. But you could also use Vertex AI, like Vertex Notebook, right, to extract data from there and then use it. I wouldn't say which one is like better approach because it really depends on how are you going to use it and what you are most comfortable with, right? So let's say if you are very proficient in SQL, you don't know much about Python or Notebook, right? And BigQuery might be the best because is you will feel right at home, right? Because you already know SQL. But if you do not know SQL a lot, don't use it a lot, but you're a Python developer or you're a machine learning developer who is using Python, then going through this Vertex Notebook route might be better for you because you can start writing Python code to train the models and things like that. Yeah, and what else? So I don't know. So another questions. I don't know much about SQL. Does it mean I cannot use this? So my short answer is no. What? Why? Because SQL basically there are, in my opinion, there are two different types, right? One, you have to write a very complex or nested SQL statement to extract the data out from joining different tables and things like that, right? So for machine learning specifically, like data engineering or some of the DBA might have done the job for you, right? One is when you are querying the data from the source specifically, for machine learning specifically, you don't really need very complex database to train model, right? So you've seen from my slides, creating models on BigQuery is only 2 steps and the syntax are not that complicated, right? So I create model name, and then some other things like model tag, right? And the hyperparameters, right? What's my labels? What kind of column do I need to exclude out and things like that. So it's not very difficult. So even if you don't know SQL, you can learn this in like a day or maybe less than a day, right? You just need to learn all the syntax, get an example. And Lavi going to also show you how to use the template as well. So you can just look through the template and you can pretty much work on it. Can I use PyTorch? I will leave this for Lavi to answer. Another question is there a possibility to connect BigQuery to other platforms? So depends on other platform. BigQuery support a lot of connector, right? So ODBC, JDBC, so pretty much all the connector are covered there. And you can also install packages. So let's say Python, we have like Google Cloud BigQuery package you can install. You can use packages and then use the same syntax, right? So one, you could use SQL syntax, send it over to BigQuery, and then BigQuery will respond you back, right? And you can even create REST API. So pretty much you can do anything, right? So my recommendation is don't start by doing it. Just try to go through from the editor, right? Go to cloud.google.com/BigQuery. Use that editor as much as possible because from editor, you can see whether your query is correct, first of all. Second thing, you can see all the stats, right? How long does it take to run? How many data I'm querying, right? And the results, you can directly see it from there. It's very nice, right? So, and you can also save the query on the platform. And one thing is don't need to install anything. So you can just kickstart right now. And it's pretty much it. And it's also control environment, right? So you cannot do a lot of things wrong, because if you don't write a correct query and you click run, it won't run. So it sort of makes sense, right? If you're just connecting from another platform, your code wrong, we don't know whether it's wrong, your code wrongs or they are wrongs, right? So only after you have satisfied with your transformation step, your model training, then I suggest you try some other platform. Right. Can I, okay, PyTorch question, I will leave Avi to answer. And yeah, so I think these are all the questions. Lavi.
Yes. Thank you so much, Toya.
No problem.
I think I'll take it from here. Abhijit, Krishna, Sujati, can you comment on the recording part once? I think a lot of people were asking that. If you guys
Yeah,
are.
Lavi, I have actually answered, but I'll just quickly mention it here that we would be uploading the recording of this video on our MachineHack page, and we would be sharing the same link to all the registrants of the participants as well as the people who are participating in the hackathon. So, and we will make it live as well. So, if that
Yeah,
helps.
so don't worry, is all I want to say to everyone. You have the recording, it'll be available somewhere or the other. So, before I share my screen, I'll quickly address the PyTorch question. So, you can't directly use PyTorch on BQ, but you can use PyTorch in GCP using AI platform. Anything related to PyTorch, you can sort of do leverage the AI platform, which is separate. BQ is a separate framework in itself when it comes to machine learning. Like it's a whole suite of data warehousing connected with machine learning. So it has its own machine learning capabilities. That's why, doing anything beyond that is not natively available. So you have TensorFlow connection if you wish to sort of do more complex deep learning solutions, but not PyTorch directly. So I think I'll share the link as well, just in case if you want to sort of explore how you can use PyTorch Lightning in the AI platform. Let me address this. I'll just share my screen. Let me know if my screen is visible.
Yeah, we can see your screen currently showing the challenge.
Okay. Perfect. So what we're going to do in the second half of this is we are essentially going to, sort of go through the notebooks that we have prepared for this hackathon. In fact, we'll take a step, one minus one step here, which is we're going to see how the prerequisites are there, because I'm sure a lot of you are already in the challenge, but there are a lot of you who would be interested in joining the challenge. So we'll go through the prerequisite. We'll try to understand what the problem statement is. And we'll also sort of touch upon the starter notebook where how you would do your first submission is sort of given. Couple of you also had questions around starter notebook that you're getting errors and all. So we'll sort of go through that. And I think in that meantime, you should be able to get answers to that, right? So I'm going to start like a very rough way, like most of you would. So the first thing that you all need to do is you need to sort of go to the prerequisites. So before you start the challenge, there are a couple of things that you need to keep in mind. The first being there's a starter notebook available. So if you click on the first link of the starter notebook, you'll get the GitHub where the notebook is available for you. And we'll sort of go through this notebook. But even before that, you need to create account on Google, right? So a couple of you did ask this question that, hey, why is it important for us to create a new account? And just to give a short answer, the reason is you can, of course, do it with your own or the previous Google account, but we wanted to make sure that you don't get into any credit issues or maybe you have something that is already part of your credit and you might exhaust it. And we don't want to get into those issues, right? So that is why what we suggest is that you create the new account. I'm going to show it live and I'm going to show you how to sort of do that. What we'll do is I'll create a very dummy one. So for example, I'm just going to copy this thing out. I'm going to say, let's try it. So Lavi Nigam. And let's say I'm going to give a random number to it, and you can see that it's there. I'm gonna give a password which is not visible to anyone. Of course, I'm not gonna do the show password, so we'll do the next. You can see that it's actually giving me lavi.nigam.2081. Please do not spam, just so that you're seeing this, because I will delete this. Um, Now you don't have to give phone number if you're in India. I'm not sure about outside India. Maybe they have made giving the phone number not optional, but in India, if you're doing it, for example, you can see it's optional. So I don't have to give any information more than my first name or last name, even if that is something you don't want. So I'm just gonna randomly select something. I'm gonna day first. I'm gonna do 1989. I can choose not to say the gender as well, and I'm just gonna hit. Oh, sorry, I selected custom rather not say next, and that's it. So once this happens, you will see that I am able to create a new account. In fact, if I'm using Chrome, and if you're using Chrome, it sort of shows you that you can create a new Chrome profile. I'm going to select no thanks, but if you wish, you can sort of do that. But what you're seeing now is that you have a new account. So for example, lavi.nigam.2081 is there, which means that I've completed the first prerequisite, right? Now, some of you have also had a question that, your quotas have been exhausted because you're doing so many different experiments. BigQuery, if you have not gotten this so far, BigQuery is not a free or an open source product, right? So it's an enterprise product, which means typically there's a cost associated with this. However, there's a free version in a sense that you can use this product for free for a certain limitation. So that limitation is nothing but 1 terabyte processing is allowed in the quota or in the account that you're trying to use it. And that's what we are sort of leveraging for this whole hackathon. So once we have finished the first bit of prerequisite, what we're going to do next is we're going to go to the Cloud Console. So it's quite simple. I'm just going to do console.cloud.google.com. I'm going to sort of connect. Currently, it is connected to my Google account. I'm going to select, and this is very important that if you are, the reason I want to show you this is because a lot of you would have pre-existing accounts which are signed up. And that's why you get errors when you're doing any kind of notebooks or all, right? So you have to be very careful that every time you're doing this, I'm just going to quickly select this, agree and continue. When you do console.google.com, make sure that you're selected that particular account. So once you are in this, again, you can see that we have sort of created this simple Google account. We are also logged in. And if you go and select the project, you will see that we don't have any project, right? So for you to start doing anything on Google Cloud, you need a project that is part of your work, right? So what I'm going to do is I'm going to create a new project, which is on the top right. I'll just quickly create this, and I can name it anything. So what I'm going to do is I'm going to call it as MH Hackathon. You can give it any name if you wish to. So let's say I'm going to say MH Hackathon Lavi. The location is, of course, no organization. And you can see, by the way, just so that everybody is clear, at no point I added a credit card or debit card, right? And this is important. You're not supposed to do that, right? Because we're not supposed to use any paid feature at this point. We're using, there's no difference as such. There's nothing like you don't get some features, but you don't put any card details anywhere, right? So I quickly create this and it sort of runs. It says create project MH Hackathon Lavi. So we'll just wait for it to be done. And you can see that it says, okay, it's created. I can now either do select project directly from here, or if I go back to this, you will see that it shows me the project as well as the ID. What is important for us to know is that we need the ID for the collab notebook. So when we'll go to the collab notebook, you're going to need this MH Hackathon ID. Do remember, sometimes the names and the IDs are not same, right? So you will have some numbers associated with your name. So always make sure that you copy the ID. You don't rely on the name of the project, right? So what I'm going to do is I'm going to do the same. I'll just copy the ID and I'm going to select the project as well, just so that it knows that this is my current project. Now, let me take a quick pause. Let me see if everybody is sort of able to understand things so far. You guys can use the chat as well or Q&A. I hope everybody is good so far. I don't see. Oh, you guys are using Q&A for yes. All right. So yeah, I think they have some questions for the presentation if you can look into.
Yeah, so I am typing that website for use cases again.
Okay, perfect. So once we are done, so we have done two major steps. So we have created the new account, which is, again, we recommend you create a new account. Doesn't mean, again, I just want to make this very clear, doesn't mean that you cannot use your existing account. The other thing that you have to be careful is, so for example, if you again see my screen on the top right, you will see start your free trial with $300 in credit, and you'll see something like activate. Now, this is completely your choice. You can actually go ahead and do the activation, but then you would have to put your card details and all, which is where I said that, maybe you can do this on your own if you wish to explore the cloud platform in general. But for this competition, you're not supposed to do that, right? You're not supposed to activate anything. You're not supposed to put any card, debit card, credit card, nothing, right? So we're going to do everything for free. Now, the other point which I mentioned, and somebody did point this out, that if you do exhaust your quota, you can do the exact same process one more time, which is just like I created the account in the first step. So the account that I just created, you can sort of create a new account. So you can say Lavi Nigam 01, Lavi Nigam 02, and in the new account, you'll again get the new quota associated with this. Do remember, and I've given the way for you to delete the account. So please make sure that once done with the hackathon by the end, do not abuse free accounts, right? So please make sure as a good user, you end up deleting those accounts as well, so that you're not going to use it any which way. So once we have all of this up and running, so we have the project ID, we have the project, we have the Google Cloud, we're going to go to the hackathon starter notebook. Now, how do you open this notebook into Collab is again very simple. When you go to the starter notebook link, so this is the starter notebook link. In this, you actually have run in Collab. You can simply click on this. So you click on the run on Collab, and this will open the notebook in the Collab itself, right? So what I'm going to do is, again, this is very important. All of you have to see how we are sort of running through this. I'm going to simply connect to the backend in Collab. Just wait for it. All right, so I'm connected. What I'm going to do is, you can see that the first thing that I need to run is I need to give the project ID, right? This is where we said that whatever project that we have created. So again, I'm going to go and copy the ID. Always make sure that you copy the ID. I copy this, I come back here, and I basically put the same ID. Now, one of the mistakes which a lot of people do, and I am doing exactly the same mistake, and I'll get the error. And in fact, I want to show you this. I'll do this, I'll run, and then I'll do the authentication of the account, and I'll do the allow, and this will sort of do the authentication as well. All right, so you can see that my authentication, so my Collab is now authenticated to use Google Cloud backend. So I'll simply do some imports, and I'm now connecting the project ID. You will see that, I don't have issues right now, but when I'll run the queries, I'll get the error. Can somebody tell me why will I get the error? And a lot of people have actually gotten error in this case. Feel free to use the chat. Anyone? Why do you think we'll get the error? Correct. So the Google account is different, right? So again, this happens, and this is a very common error that all of us get because we have the same account that has been logged in. So your main account is logged in. So I need to do that change. So I need to again open collab only in the new Google account that we have created. So now if you see, I actually have the account, which is the account that I just created. Now I will do the same step one more time. So I'm going to leave the older notebook because that was not logged in through the new account. And I'm going to do the same thing one more time, which is I'm going to paste my project ID here. I'm going to connect to the backend. Sometimes it takes time. All right, so this is done. And now I can simply sort of run these cells. I should make sure that I have project ID, which is MH Hackathon Lavi. So which means that my project ID is sort of saved there. The next thing is again authentication to the Google account. Now this is important because we need to, like I said, we need to make sure that your collab instance is connected to the backend of the Google Cloud, right? So you just have to run this cell. It'll ask you to do this authorization, and you just have to do the allow part. Now, when you do that, you can see that it actually is asking choose an account, right? So this is important. So make sure that when you do this, your account that you just created using Google Accounts is what you see here. So you can see that I just created this account. I'm going to click this and I'm going to give it all the access, and it'll run for a few seconds. Once it is done, that's it. That's all you need. And now I will run through the import of pandas. We'll use some bit of pandas in this as well. And then I'm sort of creating the client. Now we create the client because we are not using BigQuery directly. I'm going to show you the UI which Tuya actually showed, where you can actually also put directly the SQL query. But because we are trying to do like a end-to-end data science that all of us have been trained or learned how to do data science, which is like doing everything in notebook cells, doing things in Python. So that's why we need a client. The client basically connects to the BigQuery, so you can do things in Python, but then it goes and executes in the backend of BigQuery. And that is what we are doing in this step. So we are saying, hey, give me a client, and this is just like a JDBC or ODBC connection that you do with the databases as well. And it is connecting with the project ID that you have sent. So once we do that, so you can see that we are connected. Now we go and check our data. So what I'm going to do is I'm going to show you both the ways of accessing the data. One is through Python, where you have a way of sort of combining your SQL with a way to write this in Python, as well as we'll go to the BigQuery UI and we'll run the same query there as well. But couple of variables that are important. So one is the project ID, which is the MH Hackathon that we have. You don't have to change this. This is not the project ID that you have to change. This is the project ID of the actual data where it is being hosted. The ID of the data set, the train data, the test data, and the start and the end date. So we have like 3 months of this data, and this is the data that we'll sort of walk through. Again, you don't have to change any of these things. This is standard. You just have to run this. Now in the next cell, we are essentially running a very simple select star query, right? And we are limiting 5 because again, like if you remember, Thuya mentioned that there are two pricing with BigQuery, right? So one is with the processing, which is the compute part, and the other is the storing part. So we don't want to always do processing, which is very heavy, because this will sort of incur cost for you. So that's why we are always very cognizant of the fact that we are not unnecessarily processing data, because this will exhaust your quota as well. So what we'll do is we'll sort of write a simple string literal using F strings, and we'll say select star from, and then this is how you would sort of mention the table name, which is project ID, the data, and the table that you're trying to access. Now, if you want to see what this query is, what I'll also do in this line is I'm going to print the query for you, and we'll see what also the query comes out, right? So this is the query. And we'll sort of, now you can see that we are using the client and we are saying, hey, take this query that I just wrote, execute it in the backend of BigQuery. So again, see, this is one of those very important, crucial points to remember. This is not running in native Python. What is happening is it is taking your query, going in the BQ execution engine, running that for you, and then passing the data from there to your pandas data frame. So do remember this. And I say this because sometimes people have asked this during this hackathon as well, that hey, what if I want to run Python functions? What if I want to run, let's say, scikit-learn? The reason is you can run it, but when you have to scale, when you have to run, let's say, on terabyte of data, or let's say more than terabytes of data, you'll not be able to do that. So the way we are using Python here is just for the interfacing. We are saying, hey, do everything in BigQuery, but return the results to me so that I can look it into the Python. And you'll see this constantly everywhere, that we offload all processing to BQ, but we get the results out and we see that in Python. I hope that is clear with everyone, that we are not doing any native Python processing, right? All the processing is happening in the backend. So once I run this, you can see that this is the query it has run, which is select star from mhhackathon .ga4 data.ga4 underscore train. So you have these three things. And then you can see that the result that came from the BigQuery is now stored in the Python data frame, right? Again, it's not natively in Python, like the whole data is not there. You can choose to, so you can remove the limit command from here and dump the whole data into the Python. We don't expect you to do that for two main reasons. One, it will clog up your memory. So this data is not a huge data, so you can sort of easily do that, but it will still take a lot of time, because imagine you're downloading the whole millions of records from online to the offline. The second is, it doesn't make sense, right? That's the whole point of doing BigQuery, that you're trying to sort of do things at scale. You're not doing things at the scale of 100 MB data or 200 MB data. So that's why we don't want you to sort of do that. You can if you wish to. It doesn't stop you to do that. Now let's see if I were to write this query in the UI that Thuya has shown, right? So again, what I'll do is I'll go back to the Cloud Console. Uh, there's couple of ways you can do this. One is, you can, in the front itself, you'll see a run a query in BigQuery, or you can simply go to the search bar, do search for BigQuery, and you'll see the first result that comes up, and you can just click on that, right? So you have many different ways of reaching BigQuery. This is the entry page of BigQuery. So for all of you, however you reach it, whether you reach it through the search or you reach it through any other shortcuts, you will see a page that looks like this. This is what Thuya was mentioning when he said that we have a wonderful UI that you have to sort of you can play most of your queries in that. Now, again, here also you will see that we have a couple of things. For example, set up billing to upgrade full BigQuery experience. Please do not upgrade. You don't have to do that for the hackathon. Of course, if you're trying to learn BigQuery, if you're trying to sort of leverage and see how BigQuery will be useful at your end in your organization, feel free to do all of those. Just know that there's going to be a cost associated with those, right? For the hackathon, do not press on activate, do not press on upgrade. Now, what I'm going to do is I'm going to create a plus sign. So this is where the query editor is. I'm going to create the plus sign, and you will see that I get like a simple window where I can simply paste the query that was printed here, right? Or you can write your own query. You don't have to sort of always do the copy paste. Now, if you notice something which is on the top right, this is what Thuya was mentioning, right? So see, so far I've not run the query. I've just pasted it, but just by pasting it, BigQuery has sort of said that, hey, if you run this, you are going to process 2.98 GB if you were to run this, right? And this is what we were discussing, that this is like something which is kind of an intelligence, that it tells you that because you have a quota and you're charged with that, you need to make sure that you're running things in a very effective manner. So I can remove the limit if I wish to, or I can keep the limit and don't sort of do very heavy processing, right? So let me sort of run this quickly. So you can see that we are processing 2.95 GB and see the amount of time it took, right? So if I go to job, the duration is in fact roughly 0 seconds, which is to say it was sort of quickly done, right? Let me run this again and see this. So if you see again, 16.1 second is what it took, like millisecond is what it took to run 2.6 GB data. Now, again, because it's only 5 of it, it sort of didn't take much time. If I were to remove this, so let's say I remove the limit, and I run this again, it'll take a bit more time, right? So now you can see that it's taking roughly. So these are almost 4.5 million records. So you can imagine that we are processing, or we are sort of doing star of this much records. And this is what the benefit of using a tool like BigQuery is. Now, here's a question to all of you. So you can say that it took almost 16 seconds, and you can see that how much data it sort of just processed for you, which is close to, again, 4 million records. Now, can somebody tell me what is when we say BigQuery is serverless, what does that essentially mean? Can somebody tell me, like, what is the benefit of this when it says serverless? Anybody who'd like to point out? Give it a try. What do we mean by serverless? And why tools like this are important from a real world perspective? Why is this technology worth thinking about, right? That's a very common question. Like, why do I care about this, right? You guys are from Google, of course, you'll say this, but why should I care about this? So I don't see any answer, but I'm going to sort of answer that on behalf. When we say something as serverless, what you notice here is that for this query to run, you had no so I see at least one person responding. Saroj said that without having to manage the infrastructure. Correct. Absolutely. That's a correct answer, right? So for me to run this query, uh, I had to do nothing. For example, from infrastructure point, I don't have to think about, oh, do I need 10 nodes, 30 nodes, 50 nodes? Do I need this much RAM? Do I need that much RAM? The intelligence of the platform is such that when you go from 10 MB to 10 terabyte, it doesn't matter. You just write the same query. So if I were to do the same select star from any other table for that matter, for example, the NYC taxi trip, which is more and more records, like terabytes of record, it'll again take very similar times. It'll auto scale internally. It'll do all of this processing on behalf of me, and I don't have to worry about any of those infrastructure. And that's what it means when we say something as serverless technology, where you don't worry about the servers in the backend. The scaling is taken care by the platform, so you don't worry about any of those aspects. And this is the live example of that. Now, if you were to do the same thing in Python for that matter, for example, if I ask you that, hey, can you load a 4 million record into a CSV? Do you all agree that you would have to sort of think about the infrastructure? You have to think whether I do have enough memory in my laptop or not. If I do, then how would I do processing over it? So all of those things have been taken away, from your planning perspective. And this is the benefit of using a tool like BigQuery, where you don't have to worry about that. You can just focus on your code. In this case, it's SQL, and then forget about everything infrastructure from the backend. It will do the scaling for you. If you're doing very complex queries, if you're doing, huge amount of processing, it will take care for you. Like it's that intelligent from that. And again, one of the point which we usually mention is that this is the same technology that Google internally also uses for a lot of the data access that we do internally in terms of different products that we have. So it's a very tested technology that we have. It's a technology which has been used by many of the Google products. So it's not new or something, but it's very powerful in that sense. So we go back and we get the data that we have. So we have just run our first query, and you can see that it's actually a simple SQL, right? It's nothing new. BigQuery SQL is not a new SQL. It's mostly the standard SQL that you have. So you don't have to learn something new. If you know SQL, or if you want to learn a SQL, this will be sort of more than enough for you. In future, we'll have Python libraries around it as well. So we'll have native way of writing Python codes also that sort of leverages the BQ backend. But those are things which are happening or going to happen in the future. So we're going to go ahead and see what the data is. Now, this hackathon is about predicting the LTV value. So this data starts with a user sudo ID. So this is a data of Google Analytics. When you sort of put Google Analytics in a website, it sort of tracks each and every, it's tracking each and everything which is happening on the website. of course, based on the choices that you make, and you're letting the user know that, hey, I'm tracking the things that you're doing, in terms of the view that, which page they are viewing and things of that nature. So you start with a user pseudo ID, which is like a ID of a user which is there. You don't know any details of the user as such, right? You just know that there's somebody who is sort of viewing it. You also know the event of it. So for example, this particular row is a view event. So the user is sort of looking into something on the website. And then you have like huge amount of params which are part of it. Also the timestamp and the date is associated with this. And all of them have a specific LTV value. LTV again means sort of long-term value, which means that how much money or a business I can expect from the user. And that's the whole challenge all about, right? If I know some of these values, can I predict the value for other customers? So I don't have every customer who has the LTV value, but I have some customers where I have the LTV value. And that's the whole challenge that we are trying to solve in this, which is, if I were to learn through it, can I sort of then do the prediction in the later stages? So this is what our data is. It has many different columns. So for example, it has what devices have been used, what's the geo coordinate, what is the source of the traffic, what platform are they using it? Is it a web platform or a mobile platform? Are they buying anything in this? Like in this event that they're doing, are they buying something? So you also get the items and the e-commerce. Because again, think about it, the LTV value sort of depends a lot on what they are doing as an activity. So the activity could be they are buying something or they are browsing something. So they may have a sort of correlation with the LTV. And that's pretty much what we are sort of trying to do that. Now, like this is how you sort of do the access to the BigQuery, and you can now sort of just start running those queries. You can start sort of figuring out how can I do feature engineering, how can I do EDA. So I've given some of the examples in the notebook. For example, if you have to see the information schema, you would have to run this. The information schema sort of gives you each and every data type of the column. This is just like doing df.info in Python, right? So when you do this, you get to see all the columns that we have. Now, one of the very interesting aspect of the data structure that we have in terms of BigQuery is that it does support nested data. So for example, if you notice, event param essentially is an array. It's like a struct where you can have nested data. Similarly, privacy info, user property, device, geo, all of these are struct, which means that you can actually have nested dictionaries or dictionary for that matter inside a data. So it's not a flattened data. It is also not a data which is sort of the way you see typically in CSV. Now, one thing which is very important for us to know is when you do solve this problem, you would have to sort of do a group by of it, right? Because each row is a user ID and their event. For you to sort of do the prediction, you have to roll up the aggregation, right? So you have to say, okay, based on all the events the user does, I need to sort of group by and then project one single value, because that's how we do machine learning, right? We need user ID and one single value that we can send to the model. You can't sort of have hundreds of rows for a given user. So this is very important. And I've shown you how to do sort of how to do that group buys as well later. So once you do that, I can again, you can see that I'm still running the query. So let's say I again do the query print. If you want to sort of run this in the BQ as well. So again, when I'm running this query, what is happening is it's doing the processing in the BQ and then sending back the results to Collab through Python. So you can see that it tells me that there are total 3.8 million events. The total users are 2.4 lakhs roughly, and we have 92 days of data, and the registered user ID is 0. So I can again sort of copy this, go to the tab. I can create a new editor. I can do this and I'll wait, and it says the query will process 112.91 MB, right? So I'll quickly run this. You can see that it roughly takes 4 seconds, and we have the same result, right? So what you see here is exactly what is sent back when you're running this through the notebook, right? So again, please be very clear. that none of the processing is happening on your local Python instance. All the processing happens on BQ. The pandas is just sort of taking the results and showing it to you, right? So no processing happens there. So you can do this because we do have a train and the test data. So I just did this, the train data. You can do the same thing in the test data, right? So we do have two data sets for you so that you can train on one and then sort of do the test. In this also, you can see that we have roughly 4 lakh records, and these are the test data that we have. Now, let me take a pause. Let me see if you guys have any questions that we can address. There's a lot of information. Any questions? Feel free to ask. Can you share the link for the hackathon starter notebook? I think somebody can share that. It's there on the prerequisites, but I think somebody will share that. Can I assume that all of you are clear with what's happening so far and there are no further questions? Like you understand how the things are happening, how did you create the first account, then how did you create the project in the GCP, and then how did you run the collab notebook? What is that you need to make sure when you run all of those things? And then where are the processing happening? What is the kind of things that I need to do? I hope people are clear so far. Okay, perfect. Thank you so much. And so now what we're going to do is we're going to go ahead and see how do we access the nested data sets, right? So nested data is something which is just like I told you, right? If you see the information schema, you have some of the columns which are arrays, or which, in a Python term, if you have to think about arrays and struct, think that you have a dictionary there. So you have a nested dictionary inside a single column. This is what we mean by columnar data sets, what Thuya was mentioning initially, right? But how do you access that, right? If I were to access those data points and I have to sort of see, for my EDA perspective, so I'm showing some of those EDAs for you so that you know how to query those data points. So it's quite simple. What we can do is the first thing is we'll see something like event name. So like how many events can a user do on a given website, which is the column called as event name. So what I'm doing here is, and again, I want to show you how the query looks like. And we are sort of again like using a combination of Python as well as the BigQuery. So again, this is a classic example of how we did the processing in the backend of BQ, got back the results, put that result into the Plotly Express, which is a Python native, and then sort of getting the results out, right? So you see the graph was created in Python, but the data that sort of is used for that came from the BigQuery, right? So the query was quite simple. We are saying, hey, please group by event. So I wanted to see how much. So let's run this. So if I run this here, you can see that it says that, hey, it's just going to process 47 MB data. And we run this. There you go. So what it tells us is we have done a group by, simple group by, and we are also doing the order. So we know that page view has the highest amount of rows inside it. And that's pretty much what we are sort of doing the plotting in this, right? So the most common events which are happening on the website are the page view event, user engagement, scroll, view event, and things of that nature. Now, in the notebook, when you go to the information schema, I have given a couple of links for you to go in details of this whole data. Like I'm not spending too much time explaining you the whole data. But if you go into the links that I've shared, you will have all the proper details of what each column essentially means from that aspect, right? So that's the first EDA that we did, right? So in this, of course, one of the very classic thing that you will observe from a data science perspective is that, hey, purchase events, like when people are essentially buying something on the website, is such a small frequency, right? So if you see at a very high level, you have just 5,000 rows which are talking about purchase. Now, one of the features is the percentage rate of the conversion, right? So if you're saying, hey, out of page views, how many page views have been translated into purchase, you can do a simple you can do a simple division saying page view divided by the purchase in terms of the numbers, and that gives you that percentage that, okay, in my website in 3 months my average conversion ratio is this. Maybe that has something to do with the LTV values, right? I don't know, I'm just giving you an example. So that's how you have to think about the features as well while you're going through that. Now we'll see how do you do the array structures, like how do you access the array. Now, before we do that, I want to go back to the first query that we wrote just to show you what is the array struct, what is that, dictionary that we were saying that, a data in a given column, we have this nested structure. So when you do select star from this data, which is selecting all the data, and we are not doing limit here, what you will notice is something very simple, right? So you have the event date, event timestamp, event name. So this is where the name of the event is what? Select item. The column, which is called as event param, has a key and a value. How do I know this? If you notice in the BigQuery UI, you will see event param dot key and event param dot value. Now, value also can be of 4 types. It can either be a string value, int value, float value, or a double value. So this is what we said, that you have arrays and structures inside a column. Now, it is not easy for you to access it directly. You would have to sort of do some kind of unnesting, or sort of breaking the nest of the data. But what you need to understand is what is the information the event param has. So just to give you a hint again, majority of the information that you would require to solve this problem is essentially inside these structures. So with each event you have, for example, what is a session number, what is the page title, like what was the page that they were doing when they were doing select item event. Were they coming from a referral? What is the source of their page visit? So whatever page they are viewing right now, what is the source of that page, like from where are they coming to this page? Similarly, referrer, like is there any referring to the page that this has happened? You also get the page location and things of that nature. So there are many such things inside it. Now, if you go back to the notebook and let me actually print the query so that you understand. Let me run this and show you what is happening here. So we are picking one such event, which is called as page view, right? So again, I'm going to go to the UI. I'm going to print this query. Let's understand the query. So what we are doing is, we are doing unnest. We are saying unnest is very important as a query because you need to sort of unnest the event param, which is the structured data. And in that, we are selecting all the EP dot keys. What are EP dot keys? Again, if you go to the unsaved query, you can see that event param dot key is your name of the name of the property of which you want to access the value. So this is what we are doing. We are saying, hey, from this table, do the unnest of the event param as EP, and then you access the key, you say EP.key, and you're taking only the distinct value. You're not taking all the value, you're just taking the distinct value. And then you're saying, please count the number of frequency for each of those values so that I can see the distribution of each of these keys inside those values. But I'm not doing this for all the events, correct? And this is where I have a where clause here. So I'm saying I'm still doing a filter. Again, you can remove it and you can do it for all the events, but we are doing this in a very simple way. We are saying, I just want to see how many keys or how many property keys that I have for this particular page view. So when I run this, now let's run this up, and you can run the same here as well. It'll give you the exact same detail. But when I run this, now you can see the same distribution, and these are all the keys that are available only for the page view event, right? So I can see the count of it. So I know the page location, medium, source, entrances, and bunch of other things. So just like you have done this for page view event, you could do this for all the events. Now, what do you do with this is exactly what you are supposed to solve in this whole problem statement, right? You could pick out some of the features coming out of it, like page title could be very interesting feature that you can create, maybe that has something to do with the LTV. But this is a way for you to access a key. Just like you're accessing a ep.key, you can also access a ep.value. Ep.value is this. So in this, if you notice, what we are doing is we are essentially flattening the data. So we are saying, hey, I'm not interested in all the things, but I want to sort of do a simple flattening of the data. So what we are doing is we are again unnesting as EP, and we are saying, hey, just put the ep.key and then ep.value as a separate column. Now, do remember that ep.value or the value still has 4 different values, right? It could be a string, int, float, and double. So when you run this particular thing, you will see a bit of a flattened structure, not the exact flatten, but bit of a flatten, because now you have event timestamp, name of the event, which is scroll, what is the key. So the key was page title, and then the value comes inside the string value. So you have like one way of doing this, right? So this is just a way for you to sort of do the unnesting of the data. And the only tough the only tough part of accessing the nested data is the array structs, right? These are the tougher part of the whole data for you to access, because you have to do the unnest, then do the ep.key, ep.value. But if you have the struct, which is different than the actual array, so struct here essentially refers to plain dictionaries which are there. So that is quite easy to access, right? So that is very straightforward. And let me show you. So your geo, like geolocation, is actually a struct. It's not an array struct, it's a struct. So that you can simply do geo dot continent, geo dot subcontinent, geo dot country, geo dot region. So you can see that now I have event date, event timestamp, the name of the event, and the pseudo ID, so the user ID that I have. And I can simply access their internal data by just doing geo dot. So you don't have to do any unnesting here or any of those things for that matter. So this was the most important part of the data accessing that you need to figure out. And this is where we were like so excited for all of you to do this, because in real world, this is how you play with data, right? So you don't always get data, which is what you see in Kaggle, right? Which is a very plain, simple CSV file. So we wanted you to experience that similar behavior when you do data access here, right? So again, I'm going to take a quick pause before we jump to the feature engineering and the model, and see if you guys have any questions. Feel free to use Q&A. So I have one question: will not be difficult to manually check the key values for everything, and how will it be helpful, or how to select particular event? So I think in this query itself, so you're right, it's going to be very challenging for you to sort of select individual keys, because like these are 3 million records that we are talking about, right? You can just put a where clause where you can say, hey, I just want a particular event, and that particular event is essentially these are the keys which are unique in that event, right? So you actually get that, right? So in the event, which is page view, these are all the unique keys, and this is the frequency of it. Same thing you can do for the value as well. You would have to properly write a logic for it, but that's pretty much how you will do that. I hope that answers your question. Any other questions so far? Anybody? Any questions? All right. So what we're going to do is we're going to move ahead with the, oh, I see one more question. After injecting data from BigQuery, can we do ML at Collab? Yes, yes, we can. And I'll show you the example. We actually have the example of doing the feature engineering as well as the machine learning model here. So now what we're going to do is we're going to jump directly to the feature engineering. So we have done the EDA part. We have done some bit of exploration of the data. I've shown you how to do the unnesting, accessing of the nested data and all that. Now, of course, this is not very comprehensive, because that's what your job is as part of this hackathon. But we have given you bits and pieces so that it is easy for you to sort of expand on that. So again, you can do experiments on the UI if you're good with SQL. If you want queries to be dynamic, the way I have done this here, for example, my from is always dynamic, right? Just in case if I wish to change it, you can do either way. I prefer doing everything in collab because that's how, we do data science. We don't like to do data science in, let's say, a UI driven way, right? I mean, of course it's good, you can sort of just keep on building the queries after queries, but I prefer doing it in notebook. So to do it in notebook, you can sort of do it exactly the way that we have given you as an example. So to do feature engineering, the first thing that I do is I create a separate database. I create a separate data set. And to do the data set creation, what you need to do is you need to sort of just create new data sets. So it's like saying you're creating a new view, or you're creating a new part of your data, where all the new features are going to go. So to do that, again, we have given you a function. You can simply name whatever name you choose. Let's say this one is GA4 ecom feature set. And then the client sort of has a way for you to access it. So we'll simply create this. So let me see if I have this. Okay, so you can see that it says created dataset MH Hackathon Lavi. And this is the one that I created, GA4 feature set. Now, how do I know this is created? Although it says it is, I can actually go to my UI and I can simply see that I have something called as MH Hackathon dash Lavi. If I click on this, you can see that I just have a new data set here, right? So this is called as data set. You can see it's currently empty. For obvious reason, we have not filled anything here. But all your models that you're going to run, or anything related to feature engineering, data sets, models, stored procedures, will come inside this project ID that you are using. So we go back up. I create the feature table. So once you have a data set, you then create tables inside it. So do understand the hierarchy. So first is a project ID, then you create the data set. Data set is like collection of tables. It can be collection of tables. So currently you can see that I don't have any table inside it, right? So I'm now creating a table. I'm saying feature table is called, let's say, a GA4 feature train. Now you can sort of create many tables, right? You can say feature version 1 table, feature version 2 table, or whatever experiments that you're doing. And it's quite simple to do that. So the way to do this is running a query called as create or replace table. And then you mention the data set name, which we created just now. And then the feature table, which we have mentioned here. And then you write your query, whatever you want to do. In fact, what I want to do is, let's create this directly in the UI so that you see what happens. So I print this, I comment this part because this will execute it from here. So I run this. Oh, sorry, my bad. I should have the feature table running. Perfect. So this is the query that I get. I'll just copy it here. I'm going to put this in a new tab. And there you go. So what I'm doing here is, what we are doing here is, again, you can see that it tells me the query will process 142 MB data, and I'm doing create or replace table with the exact data set that I just created, which is GA4com, and the table name that I'm mentioning. What I'm doing as a feature set also is very simple, and this is just to give you a idea of how to create features. One very important thing that you will notice is that I'm grouping by the user pseudo ID, and this is what I said initially as well, right? This data, each row is not a unique row for a user. User can have multiple events, like it can go from maybe 2 or 3 events to maybe thousands of events a user can do. So I need to group by everything. I need to sort of roll up everything into a single row. So what I'm doing is I am doing a group by with the user ID, and I'm simply taking average LTV. So of course the user will have the LTV values associated with it in each row. I am just taking the average value of it, and we have mentioned this, that you have to take the average value. So we are doing the average value as average LTV. Then we are simply parsing the event date and extracting the month of year, week of year, day of the month, and day of the week. So we are using the format parse date function. Then we do the format, and then we are casting it to get the int value. Cast is basically how you do the as type in pandas. So you're sort of converting the original value to the int 64, and then you're taking the max. See, the most important is you need to have the aggregate functions in all of the features that you're building, because again, you're doing the rollover, you're doing the aggregate. So whatever feature that you come up with, you need to do max, average, min, whatever your logic says, right? You, if you want to do max, or maybe you can select the last value, first value, middle value, whatever you want, but you need some kind of an aggregation. And that's pretty much what we're doing here. So when I run this now, if I were to run this thing up, you can see that it's running on the whole data, and it takes, I think it'll take upward of 15 seconds or so. And this is what, so roughly 10 seconds. Now you can see that it doesn't show us anything, right? There's an empty thing. Why? Because it says the statement created a new table named GA4 feature. So now when you see on the left side, you will see there's a new table that got created. And that's what we wanted, because we want to persist the features, right? We don't want the features to be just randomly coming out as a result. Now, if I do the preview, this is my feature set. So I have now a user ID, I have their LTV value, and then I have these 4 features that I created, which is the month of the year, week of the year, day of the month, day of the week. Now, again, I would say that this is the worst feature that you can create. It's not a good one, but this is just to show you an example that this is how you could be doing feature engineering, and you can sort of add your own bunch of features around it. You can also check that it is actually giving you exactly the same amount of unique pseudo ID that we actually saw initially when we were doing exploration. So this means that we are not doing anything wrong, right? So once we have that, I can now run simple select star from the same table that I just created, just to see whether that table exists. And I can actually do that. So you can see I just ran it, and it actually showed me in Python as well. Again, I'm just taking the 5 values in Python. Now, a very common question is that, hey, if these are like 200,000 records, why can't I just dump everything in Python and do scikit-learn or any most common libraries? And you can. There's I'm not saying you cannot, and it's not possible. It is possible. You can do all of this, but two things, like I said previously as well, the rule of this competition is for you to do everything in BigQuery. So that's the first thing. And how do I know, or how do our team knows that you've done in BigQuery? Because you have to submit the end-to-end notebook in the end. So that's why you need to make sure that you're doing every step, because we are going to ask you that for the final model that you're submitting and which has been selected, what was the notebook that you used to do that, right? So that's one. It's as per the rule. And the second is the reason why we are enforcing it, right? Because we want you to experience how you do things at scale, because you won't be able to use Python on terabyte data. You need tools like BigQuery. You need many other tools which are similar like BigQuery, but essentially BigQuery is one of those tools which can help you do that. And that's why we are enforcing it, not because we want to sort of give you pain to learn all of this, but it's important that you learn how enterprise data science or real world data science sort of is being attacked. Now, once we have this very average weird feature set with the average LTV, now I'm going to run the model. So somebody did ask this question that, hey, can I run models directly on SQL or on the Python notebook, or do I have to sort of do something else? You can run directly on the notebook as well as on the UI, right? To do that, again, it's very simple. You have two versions of the model. So you either can use the base model where you give specific feature values, just like you do in Python, or you can use hyperparameter tuning available, which means that you can then get the models, do the automatic hyperparameter tuning. Automatic hyperparameter tuning is mostly like doing auto ML in a given single model, which means you don't have to give all the details of the values, but it'll figure out the best values for you automatically. You can still control it if you wish to, but it has a capability where you just say that, hey, these, sort of try out all the possible values and give me the best cost function for it. So let's see, how do we sort of run through the models, and it's pretty similar to how we just created a table. For example, in fact, let me put this query in the UI so that you can see what's happening. So let's put it this. So what we're doing here is we are saying create or replace model. We are using again the same data set, which is GA4 com feature set. And I've created a new name of the model. So I'm writing the name of the model as customer LTV model, which we have defined here, right? So I'm saying the name of the model is customer LTV model. You can choose to name something else. And just like parameters in the actual Python world, you have the same options there. So option, and then inside the option, you define that, hey, my model type is linear regression. My L1 regularization is 0.1, L2 reg is 1.0. I don't want to early stop. I want this to run at least 10 iterations of it. I also don't want any split to happen, which by the way, you should do the splitting, just so that you can have train and test in the trained data so that, you can do multiple iteration. Of course, you have a test data where you can do the testing, but when you do the splitting, it will be more like you'll have the eval set before the test set, right? So you'll be able to sort of run through it. You can also do the encoding directly in the options. You can also do the global explain, which is to say, what if I want to explain the results in the end, which is just like running a SHAP over the data. So you can run this right here itself. You don't have to again go back to the Python. And then you and you tell the column that you're predicting. So this is where you mention input label column is average LTV. So you're telling BigQuery that, hey, take the data, which is the feature data. You can see select star, accept pseudo ID, because of course we are not going to send the pseudo ID. Take all this data, make sure that average LTV is not null, and then send it to this model. So the moment I run this, now let's see. Oops, my bad. So moment I run this, you can see that this is now running the model on that whole data. And this will sort of take some time because you can imagine that this whole model is running 10 iterations on the 4 million records. And that's all you have to do. So this will actually run the model, and this model you can then use to predict the test data that you have, which we have given to you, and then you can sort of make the submission. We'll go through it, but let's see how much time it takes to run. But if I were to ask all of you a quick question while this runs, and I'm keeping a tab how much seconds or minutes it takes. But if I were to ask you this question, if you have 200,000 records or 400,000 records, or let's say 4 million records for that matter, how much time do you think on an average machine Python would take to run a simple linear regression? Anybody who would like to give it a try? Somebody saying 2-3 hours. Okay. 2-3 hours is slightly big. Roughly 4 minutes. Yeah. It's not going to take 2-3 hours. I'm pretty sure about that. It will be somewhere in the 10 to 20 minute, depending on how complex is your data. So, for example, this took 1 minute, and once this sort of runs, and by the way, it scales in that way. So again, every time you do something like this, do remember that if you were to scale this suddenly from 200,000, if you were to go, let's say 20,000, or let's say 2 million, 20 million, it will scale beautifully in that way. Python never scales properly in that sense, right? So this is where the problem is. This is where we are trying to sort of see what are the alternative. By the way, you can do the same thing in Spark as well. So if anybody is looking for an open alternative to do this, you can do all of this in Spark as well. You have a way to scale without worrying about too many things. So once you run this, you can see that I can now go to the model, and you can see that my model is also listed here. So I have a custom LTV model. I can go to the model, and it sort of gives me all the details that a typical model will give, right? So I can go to the training. It gives me that training loss thing. It also gives me evaluation. So I can see my R squared is 0. My mean absolute error is huge. It's a very terrible model for sure. But it also gives me the interpretability of it, right? Remember in the query, we actually mentioned global explain. So now it tells me the attribution of each column that, hey, day of week seems to be the most important, although it's a very terrible model, but at least we have the model, right? So this is what we were discussing, that you can do your whole data pre-processing in the BigQuery, But at the same time, you can also club in the whole model world into it as well. So you don't have to go outside of the ecosystem. That's what Thuya was mentioning, that this is the beauty of BigQuery. So when I go back now, I can actually again run this evaluate query, because now that my model is already run, to again see what my R square is, what is my explained variance. So you can see I have a terrible R square, right? Now, how do you do the submission? Again, somebody was saying that, how do I do the submission? So we have given you a script for it. So you can use, once you're done with the model, everything below the prediction on test and submission is something that you can use as it is. You don't have to change anything. Why? Because what you have to do, sorry, you would have to change one thing, which is your feature. So rather than this code, you will have your own code of feature, because the test data also needs to be converted into the features that the model accept, right? So I will run the same feature engineering that I ran on the train data on the test data. So this will run that. And let me see if I have the answer. So sometimes, so here's another thing which is very important for all of you to know, right? Sometimes when you run a query, and typically a query of either creating a model or creating a table takes time, right? Takes time in a sense. It takes some seconds before it gets reflected. If you run the next cell just after, right after running the create table or create model, it will throw error. Why? Because it will say, hey, I don't see any table. And of course you will not, right? Because it's still doing the processing. This also proves that the processing happens in the big query, and sometimes it takes time, right? So if I were to run this cell one more time after a moment, you will see that I'll get the answer. Right now, you know why you get the answer, because the processing was still happening. So again, if you were stuck somewhere and you're like, hey, I'm getting errors and all, make sure that in the create table process or create model process, it'll always take some time before you should execute the next cell. And if you're not sure of it, you can just print the query just like I did, and you can actually run create table and create model in the UI, so that you know that they have actually run and you're sure of it. Now, what you can do is, once I have, so now you see this is the test data features. I can simply now create my prediction table. So I can use again a new data. I can sort of do ml.predict. So if you go up when we were running the model, we were sort of just doing the create or replace model. But now what I can do is I can do a ml.predict. So ml.predict basically takes the model that you have built and applies that model to the data that you select. So I'm selecting a GA4 test data, and I'm saying, please apply the model that I created on the test data. This is just like doing dot fit, the way you do in Python. So it does the dot fit. And again, this takes time, right? So you would have to sort of wait for it before it gets processed. Once this happens, you will get a new table. We can do the select star, and this table will have the predicted average LTV. So whatever the model sort of predicts. Once you have that, let me see when I run this, if I have this or not. Like I said, take time. So you have that. So you have the prediction by the model, which you just defined. Um, and also the final submission is just two process, which is you do the subset of the data. So you take the user pseudo ID and the predicted average LTV, and then you're just creating a simple CSV file, which you then have to update in the submission. Now, one thing to always make sure is that before you do the submission or before you create the this file, make sure that you have 26760 rows in that before you do that, or else you'll get the error in the submission. And that's pretty much it. Now, of course, we are not doing the submission in a very good submission, because the models and sorry, the features were not good. But that's how you go end to end, and that's how you sort of do a scaling data science end to end using BigQuery. So let me stop here, because that's pretty much what we had. And I hope you were able to understand how to do basic things. If you go to the hackathon, we have given you a couple of resources. So for example, somebody is asking, what are you going to judge in submission? So of course, the two thing is, one is you should be in the leaderboard, like the top folks in the leaderboards, and you should have a notebook, which is using BigQuery to do the submission. But along with that, we have given you these pointers that how will we judge the notebooks, right? So of, let's say, the top n people, if they're very close in numbers, then these are the things that we will sort of notice when we'll do the judging. We have given you a resources tab. So for some of you, if you want to sort of go and understand many of the things, for example, how many models can I play with? What are different models that I can play with? We have given you some of these resources. If you're also not clear with how to do things in SQL, we have again given you those resources as well. So that's pretty much from my side.